Okay, we're going to look at something called quadratic inequalities. Okay, first note to take down with this one is quadratic inequalities must be solved using a sketch of the quadratic function. Okay, so to solve these questions, you absolutely must make a sketch. Okay. So what's a quadratic inequality? Well, it's pretty easy to explain what one is. So let's take this down. X squared plus 5x minus 14 is less than 0. Okay. Now, if that had said equals there, you would say that the thing is a quadratic equation. Alright. You've got a lot of experience in that. However, it's got the x squared, which means it's a quadratic. It's got a less than, which is an inequality. Therefore, we would describe that as a quadratic inequality. Alright, now since it is a quadratic inequality, we must make a sketch. So as soon as I see that, I think to myself, right, it's a quadratic inequality, therefore I must make a sketch of the quadratic function. Okay, so let's take it down again. X squared plus 5x minus 14 is less than 0. Okay, now straight off what we can say is because it's a positive x squared, we looked at this with completing the square. Immediately we know that that is a concave down parabola. Okay, now my next thing is to look at the roots. Okay, so to look at the roots, I'm going to make the thing equal to 0. Okay, so eventually I'm interested in when this quadratic inequality is less than 0. So let's first of all explore what is equal to 0. And that means I find the roots. Okay, so two numbers I multiply give minus 14, and together give 5. That's going to be 7 and minus 2. X plus 7 is equal to 0. X minus 2 is equal to 0. X equals minus 7 and x is equal to 2. Okay, we know that it's concave down, so we can now make a decent sketch. With a root at minus 7 and a root at 2. Okay, now we are interested in when this thing is less than 0. Now it's less than 0 below the x-axis. So what I'm going to do is just make a sketch as to what that means. It's in here. Okay, so where is the curve x squared plus 5x minus 14? Well, there is the curve x squared plus 5x minus 14. Now where is it less than 0? It's less than 0 below the x-axis. Where is it greater than 0? Above the x-axis, but we're interested in where it's less than 0, which is below the x-axis, which is in here. Now that basically means it's between minus 7 and 2. Okay. Now, the way we're going to write that is that. Now, that's called a closed interval inequality. So let's take that down. Now what that basically means is that the thing's closed off, and you can say that it is. Okay, it's bound between minus 7 and 2, and we've got this bit here that is closed off. Okay, and this basically means between minus 7 and 2. Now, why does that mean between minus 7 and 2? Well, if you think about what that means, minus 7 is less than x is less than 2. Well, if I look at that first bit of it, minus 7 is less than x. Well, if minus 7 is less than x, it follows it's a quite simple thing to think of, which is minus 7 is less than x. What does that mean? That means x must be more than minus 7. So it's just saying the same statement but back to front. Okay, so minus 7 is less than x, which means that x must be more than minus 7. so as well as that being the case, we also know that x is less than 2. So that statement altogether in one line is saying that x is more than minus 7, but it's less than 2. So it's more than minus 7, but it's less than 2. So what does that mean? It's between minus 7 and 2. So let's just go over that again. Alright. So the statement is minus 7 is less than x is less than 2. So what I'm saying is that's between minus 7 and 2. Now, how does that follow? Well, minus 7 is less than x is less than 2. Well, if minus 7 is less than x, that obviously means that x must be more than minus 7. But as well as the statement saying the first bit, it's also saying the second bit, which is x is less than 2. So x is more than minus 7, but it's less than 2, which means it must be in here, i.e. it's between minus 7 and 2. Okay, let's try an example 2, which is going to be x squared minus 3x minus 10 is less than 0. Okay, so first of all, what type of equation is this? It's a quadratic and it's got an inequality, therefore it must be a quadratic inequality. Okay, so what does that mean? That means from the note advises me then I must make a sketch. First thing is it's a positive x squared, therefore it's concave down. I'm then looking for two numbers that multiply give minus 3. Sorry, two numbers that multiply give minus 10 and that together give minus 3, so that's minus 5 and plus 2. So I'm going to first of all explore the roots by making the thing equal to 0. Two numbers that multiply give minus 10, add together to give minus 3, that's minus 5 and 2, minus 5 times 2 is minus 10, minus 5 plus 2 is minus 3. Okay, so now I've got x minus 5 could be 0, or x plus 2 could be 0, which is x equals 5, or x equals minus 2. Okay, so I've got a root at minus 2 and a root at 5, it's concave down. Okay, I'm interested in when the thing's less than 0. The thing is less than 0 when it's below the x-axis, that's when it holds a negative value. So what that is, that's between minus 2 and 5. Final answer. Let's try an example 3. Okay, example 3. X squared plus 7x plus 12 is greater than 0. Okay, it's a quadratic inequality. I'll need to make a sketch. It's a positive x squared, therefore it's concave down. Two numbers multiply give 12, add together gives 7, is 3 and 4. So I'm going to first of all find the roots by making the thing equal to 0. Okay, x plus 3 could be 0, x plus 4 could be 0, x equals minus 3, x equals minus 4. I'll sketch it out, concave down, I've got a root at minus 3, I've got a root at minus 4. Okay, this time I'm interested in when the thing is greater than 0. So greater than 0 is when it's above the x-axis, so let's just sketch in that area. And where is the thing above the x-axis? What's above the x-axis before we get to minus 4 and after minus 3? If you think about what's happening here, is it's either equal or below the x-axis, so that's not of interest. What's of interest is it's above the x-axis here and it's above the x-axis here. So where's that? X is less than minus 4 and x is greater than minus 3. Okay, example 4. Example 4. X squared minus 7x is less than or equal to 0. Okay, first of all, let's interpret what type of question it is. It's a quadratic, it's an inequality, it's a quadratic inequality. Okay, it's a positive x squared, concave down. Okay, let's first of all find the roots by making the thing equal to 0 and factorise. So that's given me x equals 0 or x minus 7 equals 0. So the roots are 0 and 7. Okay, it's concave down. There's 0, there's 7. I'm interested in where the thing is less than or equal to 0. So less than 0 means underneath the x-axis, and equal 0 means including on the x-axis. So that's between 0 and 7, but also including 0 and 7. So that would be the less than or equal bit would finish that up. Okay, example 5. Example 5, x squared plus 6x minus 27 is less than or equal to 0. Okay, first of all, it's a quadratic inequality, so I'm going to need to make a sketch. I'm going to find the roots. It's a positive x squared, it's concave down. Let's make the thing equal to 0. X squared plus 6x minus 27 is equal to 0. Two numbers that multiply give minus 27, add together give 6, that's plus 9 and minus 3. X plus 9 bracket x minus 3 equals 0. X plus 9 is 0, x minus 3 is 0. Bring them across, change your sign, x equals minus 9 and x equals 3. Okay, it's concave down. I've got a root at 3 and a root at minus 9. Okay, I'm interested in when the thing is less than or equal to 0. So there's less than and there's equals. Where does that occur? Between minus 9 and 3, but also including minus 9 and 3. Okay, example 6. 5x squared minus 15x is greater than or equal to 0. It's a quadratic inequality. I'll need to make a sketch. It's a positive x squared, it's concave down. Okay, so it's falling into those routines. Okay, first move, take out highest common factor, which is 5x, bracket x minus 3. So my first move is to find the roots by making the thing equal to 0. I've then get 5x equals 0 and x minus 3 is equal to 0. 5x is 0 and x is equal to 0. And x equals 3 is concave down. Okay, so I'm interested in when the thing's greater than or equal to 0, so it's greater than 0. Well, if you think about it, where's it greater than 0? Well, it's after 3, because between 0 and 3 it's less than 0. It's after 3 and it's before 0. But it also includes 0 and 3, because I'm not interested in just where it's greater than 0, but it's where it's greater than or equal to 0. So it's greater than 0 after 3, before 0, and it's equal to 0 on the x-axis at 0 and 3. So where does this occur? At and before 0, less than or equal to 0, and at and after 3, x is greater than or equal to 3. Okay, let's try one more. We're going to solve 2x squared minus 5x minus 3 is less than 0. Okay, the first thing, it's a positive x squared, it's concave down. Next move, find the roots, make the thing equal to 0. And what type of question is it? It is a quadratic inequality. I'll need a sketch. Okay, so 2 times minus 3 is minus 6. Two numbers that multiply give minus 6 and add together to give minus 5 is minus 6 and 1. 2x in there, 2x in there. I can simplify that down to x minus 3. Okay, so that'll be x minus 3 equals 0, or 2x plus 1 equals 0. X equals 3, 2x equals minus 1, and x equals minus 1 over 2. Okay, I can now sketch the thing out. Concave down. I've got a root at minus 1/2 and a root at 3. I'm interested in where the thing is less than 0. It's less than 0 down here. That's a closed interval, and it's between minus 1/2 and 3. Final answer. Okay, have a go at those 5 and we'll pick that up on Monday.